Rho 1 equal to how much? Mass by volume. What about here? The density will be very high because volume is almost negligible, density will be. So you can call like this is super dense material. So point mass means not like a negligible mass. This is something very important. Point mass means not like a negligible mass. Volume will be zero, that one. So we can have a point mass. Point mass. So this m1 equal to how much? It can be milligram or microgram, 10 to the power of minus 6 kg. Then I can also bring a mass which will be of like a 0.2 kg. I can also have point mass 12 kg like what earlier I'm shown. I can have the point mass Euclid this shall we say this M4 is a super dense material, super dense, because you see such a heavy mass or when is concentrated at a single point, this will become super dense material. So point mass means not negligible mass. Okay, I agree this. The basic idea of the point mass. So what all the Newton's laws of gravitation, what we define now, it is just is describing about the for point masses here. So we will take 2 point masses which are separated by distance r. Then it's telling they are going to interact. They are going to interact. The force of interaction here will be like this here. There's the force of interaction between those 2 point masses. And this force of interaction, it is directly proportional to product of masses, inversely proportional to square of distance between them. To remove that proportionality, you will introduce a constant called as a gravitational constant. It's an empirical constant, that one. So this particular force of interaction depends upon product of masses, directly proportional product of masses, inversely proportional to square of distance between the point masses here. And what is G? G is a gravitational constant, 6.67 into 10 to the power of minus 11. Can we write anything? Kg. This what is a force? Force will have Newton meter square per kg square. Further Newton force what you can write? M into A. So here only we'll try to analyze this one. So what is M? M is a meter square, Newton, kg square, that one. Or you can further write what is M? What is the force equal to mass into acceleration? So this will be kg dimensions. This will be meter per second.
The second square, sir.
So okay, sorry, this one. So this will have dimensions of meter per second square, no? Yeah. Okay, now substitute or just leave it. It's left to you, that one. So what can be further simplification of this? It will be Newton meter square per kg square. Keep it in this way. That will be useful for us. Or meter cube per kg. Kg per second. So it's left to you. So or else I'll write it here. Only this unit. Or else you convert kg per second meter cube. Either of thing. This is what usually popularly what we use, the unit for this. Sometimes they may test you like this also. There's like a gravitational constant. It is determined experimentally. Now, what is the thing like? What is this force? So it is having some very characteristics which till now we didn't notice. What are the characteristics like? It obeys inverse square law. So this force obeys inverse square law. And how did it act? This features of F, will write it. F obeys inverse square law. Next again, it always acts along the line joining the point masses. Next again, one more. It always acts along line joining the point masses. It's a conservative force. F is a later on in depth I'll show that how it's a conservative. Time being, I'm just putting a statement here. It's a conservative force. There's a thing. Uh, so these are the preliminary things. Okay, later on as I get into the E equal to dou V by dou X, I'll define potential. There few more features will add up that one. Is this central or not? When you get into Kepler's law, there will exclude here. And it's a field force. F is a field force. So now you always maximum, your entire this chapter is what? Trying to understand what do you mean by field. This is what you have to put effort. Now, is it a contact force? No, it's a field force. So are these two point masses in contact? No, they're not in contact. Still, they'll exert a force. I think this is the first time you are coming across here. No, the particles are not in contact. They'll exert force on each other. That's what he's saying. That one, and this particular force what will obey the superposition principle. Will obey the principle of linearity, linearity and superposition principle. What do you mean by that? If you take particles, let me take particles, three particles. Let the masses be m, time being. Let me take equal masses here. So let this particle 1, 2, and this is 3. How the force of interaction between 1, 2, it will be like this. Oh, no, this will be 1, 2. Similarly, sorry, this is 1, 3, no? Similarly, what happened? F31 will be like this. F12 will be like this. And F21. This is force experienced by 2 due to 3. Force experienced by 3 due to 1. And they are placed at the equilateral triangle, corners of equilateral triangle. Then when you are calculating F12, so in general, okay, let's first look at F12. What is F12? You are going to write F12 or F21. You're going to write Gm1m2 by L square. F32. Yeah. Now Gm1m2 by L square. So there's the force of interaction between 1 and 2. Look at this particular force of interaction. It is independent of the presence of third mass, presence or absence of third mass. This will not influence the interaction between these two. And this is something very fundamental, which is going to help us a lot as we proceed. This is called like a principle of how to linearity. That one means the interaction between two objects is independent of the presence or absence of n objects in a system. Means in a system, so what is a system? It contains three particles. The interaction between 1 2 is independent of what? The presence of other particles in the system. Let it not only third, you can bring any other objects here. The presence of the third object will not influence the interaction between 1 2. This particular force, the interaction between 1 2 or depend is independent of this particular presence of this object. Similarly, or we can generalize here, F12 equal to F21, F13 equal to F31 magnitude, F32 equal to F23 equal to G That's what he's saying. So what is the conclusion I can make it? The interaction between two given point masses is independent of presence of third point mass. This is more generalized. We say the interaction between two bodies is independent of the presence of the third body. It doesn't matter. Now, how to calculate the force on one? Just take the superposition principle. Means you calculate first F12 as if the third point mass is not present. Then again, remove this particular mass. Then you calculate 1, 3. Then take superposition. You get the net force. So what is the net force acting on the, what is F1 bar? F1 bar, you're going to write it as F12 bar plus F13 bar. Agree this? Like this, we can directly write that one. Similarly, what is F2 bar? F21 bar plus F23 bar. Similarly, what is net force acting on this? F31 bar plus F32 bar. So like this is what the method is being suggested. This is called a superposition principle. I think we need to bother now more than two objects are there. How do, sir, how do that force of interaction? Yes, you calculate first force of interaction between 1, 2, then 1, 3. Then take the vector sum, you'll get it. Nothing but I'm calculating 1, 2 as if the third is not present. Then I'm calculating 1, 3 as if 2 is not present. Then I will add up these two. That will be the resultant force acting on the particle 1. This is called a principle of superposition. I think this is what going to help us a lot when we get into numerical, because I can have a system where more than two bodies will be there. Then what to do? We'll just carry on this particular analysis. Okay, now this force is acting. What is this force? Again, all these are field forces. What all we talk about gravitational force is a field force. And what will happen to, because of field force, it will accelerate. If I leave these particles, so what will happen to them? Next question comes. What will happen to them? Is how the force F1 will act. The resultant force F1 will be, sir, how do you can say? Because F magnitudes are equal, no? And they'll start accelerating. So what is acceleration A1? A1 equal to F1 by M. A2 equal to F2 by M. Means that this gravitational force, can it accelerate a charged particle? Yes. It can accelerate, it can retard, it can set up a torque. All again go back to the mechanics. That is what our primary goal. This particular force or pen, it can drag an object. It can exert a force. It can do work also. It will accelerate means then what happens? Its speed will increase, no? The speed of particles will increase. The kinetic energy of particles starts increasing. Okay, no? So this is the, there's a very generalized approach is what we are going to develop here. Sir, is it only three particles? Even if four particles are there, will they interact? Yes, the interaction will continue. Let me put it some masses like this. Need not to exactly equal masses. And I'll give the name 1. Okay, anyway, there's M2M is there. What about the force F12? The force F12 will act like this. The force F14 along line joining. What about force F13? Similarly, here force F21,
Sir, F13, sir.
F13 a symbol. Okay, this one. F24, F23,
Sir, F3 4, sir.
F3 4. Yeah, thank you. F4 2, F4 3. Now what about now the forces acting on particles? Will it be same or different? I am asking the net force F1. Is it F1 equal to F2? Need not know. Need not. Will the acceleration of all the particles will be directed towards a center O? Need not. If you calculate the net force on the particle 1, F1 to F1 4. F1 4 definitely greater than F1 2. So somewhere here it may come the resultant. Clear this? I'm just showing, going to show the rough F1 will be somewhere here. Sir, how do you can say? See, F1 4 will be greater than F1 2. Roughly that one. Similarly, what happened? F1 2, F2 1, and F2 for this one. So somewhere it will come like this. What happened? We can find out. And every time need not F1 need not be equal to F2. I can sure say that F1 not equal to F2 not equal to F3 not equal to F4. If you want, you can check it. So I may get particles of same mass or different particles, different mass. Altogether, what happens? How to calculate F1? Next question comes. What is F1 bar? I'll show one. So it should be the vector sum of all the resultant, all the individual forces that are acting. So F1 3 bar. When you're calculating F1 2, what to do with 3 and 4? Assume as if they are not there. Calculate F1 2. Then when you're calculating F1 4, assume as if only 1 4 are there, 2 3 not there. So when you're calculating F1 3, assume that 2 4 not there, only calculate F1 3. Then you take the superposition. So what is this F1? When all three are present, what force is acting? The same force is what we are going to get it. I think, tell me like which is the best method? This is the best superposition principle, no? So this is a binding thing, means like this is a core idea which our entire chapter revolves around it. So gravitational force obeys law of superposition principle. Correct statement. This is what happens for you in conceptual question. The small ideas are brought from here. So gravitational force obeys. See, you may feel this is something very simple, just mathematics, but our entire physics revolves around the superposition principle. So as we proceed into waves and sound, electromagnetic waves, there you can see that superposition principle is what that will help us to explore the higher levels of physics. Okay, this is about the field. Again, all these are field force. Yes, all the forces F1, F2, F3, what all